Hello and welcome back to our project Athena. In the last video, we had a look at S3, so we understood how this cloud storage works and we uploaded our source data to it. So in this video, it's finally time to understand Athena. Let's start with that right now. So back on aws.amazon.com, and before we start, let's quickly think about what we know about Athena so far. Because we know that we can use Athena to query or by that access information that is stored in S3. And the important thing is, of course, that we can work with that information, but we won't change any information in the source files. So Athena is a read-only service. That's just important to know. However, where can we find Athena now, or where can we find additional information about it? Well, as I said, we are back on aws.amazon.com, and as always, if we go to products right here, then we can find Athena right here in the analytics section. So if we click onto it, well, then as always, if you scroll down right here, you can get lots of information about Athena. But as I said, we know that we can use it to query our data, and that's enough for the moment. But there is one important thing though that I would like to show you. And that's again, as for S3, related to the pricing. So let's click right here. So here you can see that for each terabyte of data that you scan, you have to pay $5. Now what does this mean basically? Well, each time you run a query in Athena, well, this query will analyze a certain amount of data, so a file size. And well, this will then be charged to you based on that pricing schema. But there is more to know. If you scroll down a little bit more, right here, then you can see, well, that you are charged for the number of bytes scanned, of course. But the important thing is that each query, so each scan that you make, will be charged with a minimum of 10 megabytes. So if you have smaller files, you will always pay at least for 10 megabytes of data scanned. And there is one important thing though, because if you run DDL statements, so data definition language statements right here, we will talk about that in a few minutes by the way, then you won't be charged. That's important to know. Additionally, if you have failed queries, for example, right here, then you also won't be charged. So take a look at this pricing before you start working with Athena. However, we will talk about these details, especially about what this DDL, this data definition language statements are in the next minutes, as I just said. But as we now talked about the pricing, I think we are now ready to start working in Athena. Well, and as always, if we want to start working with an AWS service, then we simply have to sign in to the console right here. And here we have our management console and can simply type Athena right there and select it. And now we opened Athena for the first time. And before we start working in Athena right now, make sure that the location that you selected, you can find it up there in the right upper part of the screen, is equal to the one that you selected for your data in S3, so when you created that bucket. Keep that in mind because we will use the same location for S3, for Athena, and for QuickSight in the next video. As we know that right now, we cannot start our work in Athena. So as you may have never seen this before right here, I think it makes sense to take a very quick look at the general interface to make sure that you understand what you can see right here. Well, in this left column right there, you can see two things. You can see the database and you can see tables. At the moment we have a default database in here, but we won't use that. The important thing that you have to know for the moment is that a database simply describes kind of a grouping of different tables. So if you select a database later on, then you can see all the tables that are included in that database right here. We will create tables and by that a database in the next minutes, so you will understand all about that. If you look at this window right here, well, then you can see that this is the window where you can type your SQL functions. We will also see how this works. Well, and as soon as you type your code in here, this is just an example code by the way, then you can click onto Run Query down here. And if you scroll down a little bit, then you can see the results of this query that you make, so of this data request basically, down there. So let's scroll up again. Additionally, you can also save your queries right here. format queries, or simply say that you want to start a new query right there. We also have some different, kind of windows up here, but we will talk about these also in the next minutes. But that's the basic interface actually. And as you can see, it's not that complicated actually, so it's quite structured. And now I talked about the interface, but I think now you want to start, right? So let's do this. And to start, we need to create a table first, or add a table actually. And you can find this function right here. So if you click on to add table now, and now we can see that this menu opens. And in this menu, we can now define if we want to create a new database or if we want to use the default database. You remember that's that standard database that's already included in Athena. We don't want to use this database, so we will create a new one by clicking right here. And now we have to define a name for our database. So let's maybe call it YouTube population, maybe something like that. And as I said before, we now have that database and by that the name of our grouping of different tables. So now we need tables actually. And that's the next part. We now have to define a table name. This table name has to be globally unique, so don't name it the same way I do it right now, right here. So I will call it maybe YouTube population again, and table, like that. So now we got the database, now we got the table, so let's scroll down maybe. And here we can see that we now have to define the location of our input data set. And that's where S3 comes into play. And that's the reason why we talked about it in the last video, why we created that bucket and the folder, and why we uploaded our source files into that folder. So as I talk about S3 now, we should open S3. Let's do this. Back in our management console, we simply type S3 right here and open it. Now we can see all the different buckets that I have. As I said, I got some more buckets in here. But if you scroll down, then you can see your YouTube project Athena bucket. This is also a globally unique name, so it's named differently in your case. However, if we click onto it, then we can see our 3 folders that we created. And if we now open the first folder, so file 1 and 2, right here, and now click onto one of the files that we stored in that folder, so for example this one, and then scroll down a little bit, then we can find this link to this file. And we need to copy parts of this link. So let's select it right here until right there. So it should include the folder name. So let's copy that and go back to Athena. And now if you take a look at the structure that this link should have, then we need, S3, the points and the 2 slashes. And now we can paste our link, select it right here, and delete it up to there. Let's now delete that. And as you can see, we simply need the link to the bucket or the bucket name and the folder name. And with that, we now get the link to our S3 folder. Now, what else can we do right here? Well, we could specify that this is an encrypted dataset. We also talked about that in the last video. We can use encrypted datasets or access encrypted datasets. In our case, we don't have such a dataset, so we can keep that unticked. Well, and then we can simply press onto next right here. And now you see that you have lots of different data formats that you can access using Athena. Now, in our case, we simply uploaded CSV files, so we can select CSV right here, like that, and press next down here. And now we have to specify the column names in our source file, so basically some metadata to make sure that Athena can read out the information and name the columns correctly. Now we have 2 ways how we can do this. One way would be to simply type the column name right here, and then define the column type in that menu. But, if you have lots of columns, then this is not really comfortable. So let's take another look at the source files. And I don't mean the source files that we uploaded into S3. I mean the source files that you can find when you take a look at the link down there in the video description. If you do that, then you can find the following 5 files. We have the 4 files right here that we uploaded to S3, so our source files, and this column names CSV. Let's maybe open that with the text editor. And in there, you can see that this file, includes the column names. And this has a simple reason. because the other source files don't include any column names. We can check that quickly if you want to by clicking right here and opening this file, for example. And as you can see, it directly starts with the data in it. And this has a reason. If we would include the column name right here, then Athena would do the following. It would read out the information according to the column names that we now define in Athena in the step we are currently working on. And additionally, in the first row then, it would again display the column names that would be in this file. Because at the moment, the SQL function that explains Athena to skip the first row, which would be the column names right here, is not implemented yet. And that's the reason why we separated the column names and the information right here. So that's important. If you want to work with data in Athena, make sure to take a look at the source files first to make sure that the column names are not included in these files. Now, after we know that, we can close this file right here and simply select this data right there. If we now copy that and go back to Athena, well, then we can now use this bulk add columns function right here. If we click onto that, then we can see that we can add different columns based on the definition that we can find right here. So we have the column name, a space, and then the data type. So let's first paste the information that we just copied right here, like that. And well, now we have to specify the data type for each column. Now we have the location ID right here, for example. So let's write a space and write int for integer. If we now select the 3 letters and the space and copy that, well, then we can add that also for the time, because that's going to be the year. For the male population, because that's also an integer, for the female population, right here, and for the total population. Now with that, we defined the columns that should be displayed as an integer, but we also have other columns right here, like the location, which is a country in our case. So let's type another space, so I selected the part right here, and write string, like that. We can again select that now, like this, and copy it, and paste it after age group, like that. After age group start, right here. After age group span, right there. And well, that's it actually, right? So now we got all the columns and we got the data type specified for each column. Well, and with that, we can now simply press add right here. And as you can see, you now get an overview of all the columns that you specified, and you could also change the data type right here, but we did it correctly, so we don't need to change that. And if you scroll down right now, well, then you can click onto next right here. Then we could add or configure partitions, which would simply mean that we could create subdirectories and by that, well, make the filtering or the querying process in our data more efficient. This is really important if you have a really big data set, but for our first Athena project with that rather small data set actually, this is not required at this stage. So let's press create table right now to, well, create the table and by that create the database. Well, and now we got it. Now we have our database in here, which you can see right here, right? We have the default database and our YouTube population database now. And we have created our table right there. And if you click onto that, like this, then you can see all the different columns that we created with the corresponding data types that we defined. So this is really great actually. And we will talk about the details regarding that in a few minutes. But the important thing now is that if you look at our, well, SQL function window right here, then we see some code right there. Now, what's the reason why this is displayed? Well, we created that table and that database with an implemented, well, interface actually by AWS or by Athena. But generally, you can also create this database and this table by running SQL functions like that. And I think now it's the time to take a look at the documentation together to understand what type of SQL functions we can use in Athena and for what functions we will be charged and what functions or what queries are for free. Because I mentioned that back in the pricing, or we could read that back in the pricing actually, that we are not charged for each query that we run. And to find the documentation, you can simply click onto help right here. Let's do this now. And here you can find some general information about Athena, of course, but the important thing now is that if you go down to reference and click onto the plus, and then go to SQL and HiveQL reference right here, well, then you can see that Athena is based on the Hive Metastore and Presto. Well, we will not talk about the details regarding the Metastore and Presto right now. The important thing is that if you open the Hive Metastore right here, maybe in a new tab, then you can find it right there in a few seconds, like this. Then you can see that this is the data definition language used in Athena. And this simply means that this is the language that you use to create your metadata actually. So basically everything that you need to create your database or your tables. This also includes things like renaming columns, for example. We will take a look at that in the next minutes. So the important thing is that these statements that you can find right here, so if you scroll down, you can find lots of examples for different statements that you can use in Athena. Let's scroll up maybe. That these statements, or when you run these statements by running a query, then you won't be charged for these type of statements. And this means that the creation of the database and the table, which used this DDL language, was not charged to us. That's really important to know, because if you now go back to the documentation right here, then you can also see that Athena is based on Presto too. Let's take a closer look at that now, because if you scroll down right here, then you can see that you can use the select function, of course, we will use that. Then you can also see the supported DDL statements right here, and also unsupported DDL statements. So that's important when you work with Athena. Make sure to take a close look at the documentation to find the functions that are supported and that are not supported. However, we wanted to take a look at Presto, so if you scroll down now, then you can find the supported functions Athena has regarding Presto. So if you open that functions and operators right here in the official Presto documentation, if you scroll down, then you can find all the functions and operators supported in Athena. And if you run queries with these functions, well, then you will be charged. And that's the important thing that you have to keep in mind. So creating metadata, creating databases and working on the tables will not be charged as it uses the DDL language. If you use Presto and by that really want to get information out of your data, then you will be charged. That's the important thing that you have to keep in mind. However, with this information and with the documentation, we are now ready to dive deeper into Athena. So let's go back to Athena then, right here. And well, as we have that DDL code already here, I think it might make sense to show you some of these functions so that you get a better feeling for that. So before we continue, let's maybe save that statement right here. As I said in the beginning when we talked about the interface, we can simply save queries by clicking Save As right here. And let's maybe call that DDL1. I don't know, you can name that just as you prefer. So let's press Save right now. And if you now go to Saved Queries right here in that menu, then we have our saved queries right here. So that's our DDL1 query. Additionally, if you go to history right there, then you can also find this query right here. So you got kind of two backups. You got the automatically created history right here, and you got your saved queries to save specific queries that you want to have or that you want to use later on maybe. So that's saved queries and history. But if you now go back to the query editor right here, so now we have our YouTube population database and we have our YouTube population table. And if you open that, then you can see all of the different columns. That's nice. But we uploaded more files into S3. Actually, we got 3 different folders. So now it's the time to add these folders to our database, and by that, to add 2 new tables. Now we could again do this by simply pressing Add Table right here. But as we got that code already in our save query, why don't we just use that? I think this makes it a lot easier. So if we go to Save Queries again, right here, now select that DDL1 query as we named it, well, then we can see that this query appears again right here. Now, if we change 2 things actually in that code, then we will see that we can automatically create a new table. Well, the first thing we have to change is, well, we simply have to rename that table right here to I don't know, YouTube table 2 maybe, like that. And the second thing is, down there, in this line, well, we have to change the file location, because the file location is not file 1 and 2, so I'm talking about that folder right here, but it's, I don't know, let's check it out by going back to S3 and going back to the bucket. It's file -3 -clean. So let's go back to Athena and change that to file -3 and change that and clean. And that's it actually. With that, we should now be able to create a new table named YouTube population table 2 in our YouTube population database. Let's run the query by pressing right here or by pressing Control and Enter. Well, and as you can see, this worked perfectly. We now have our second table right here. And again, if we want to, we can also save that by pressing Save As and simply naming it maybe DDL2 and pressing Save. Now this query is also saved. Now we have that second table, but we also have a third table. Now we know how this works, so we can do this quite quickly by clicking right here, deleting the 2, adding 3, and changing it from file 3 clean to file 3 error. You remember, if we go back to S3, then this is the name of our third folder, like that. So if we go back to Athena now, and now press Control and Enter once again, and with that, we now created our 3 different tables. Let's maybe also save this query by pressing Save As and name it DDL3. So we also got this one. So we still are in this DDL, this data definition language word. This means we are still kind of creating our metadata. But what if you added a table that you don't want to add actually? How can you delete a table, or how can you even delete an entire database? Well, you have 2 options how to do this. Let's say you want to delete the third table, the one that we just created. Well, then you can go to the catalog manager right here and go to YouTube population, so our database. So I'm clicking onto the name, and then you can select each of the specific tables that we created. So if you want to delete the third table, you simply click right here to this box and then press drop. I won't do that right now because we still need a table. But that would be one option how to delete a table. The option with the integrated interface actually. But there is also a way how to do that directly by just using some DDL code. So if we go back to the query editor now and then go to the DDL documentation right here, then you can see that you have different options how to work with databases and tables right here. So we want to delete a table, so we can simply click right here onto create, drop or truncate table right here. Then you can find, well, lots of creating table options, that's interesting, but we want to drop the table right here. So if you click onto that, well, then you can find the following statement. You can simply copy that actually, go back to Athena, now simply paste it right here. Well, the if exists, we don't need that term, so we can actually delete that. Now we have to specify a table name, which would be YouTube. And if you now press Control and Space, then you can see that you can select, well, the database, which is wrong in our case, and the 3 different tables. So let's maybe select the third one and press Tab. And the purge, yeah, this can be in, this is not a problem. And if we now run the query, again, I'm pressing Control and Enter, like that, well, then you can see that our table is gone right now. So this is one way how to delete a table using the DDL code. But what if you want to delete the entire database that you created? Well, then you also have 2 options how to do this. The first option is, again, if you go to the catalog manager and then select the database right here. If you then press drop right here, well, then you would delete that database. That's again the solution with the integrated interface. But if you go back to the query editor now, well, then you might again do this by using some DDL code. And to do this, we can go back again to our DDL documentation right here. And if you now scroll back up right here to the beginning, you can see all the different topics that we have. Then you can select the create, drop, alter, use database option right here. And now you can find drop database right there. If you again, well, select that like this, go back to Athena and again paste it right here. Well, then you can say drop database like that, right? This is it. If exists, well, we don't need that because we know our database is existing. Then we have to define the database name, which would be YouTube population, like that. And we can keep the cascade command. This is fine actually. And now again press Ctrl and Enter. Well, then you see that our database, and with that of course, all our tables are gone. So this is the way how to delete the database using the DDL code. Now the problem is that we don't have any information in Athena right now. The good thing is that we saved the queries. So if you simply go to Save Queries right here, now select our DDL1 query, and now simply press Ctrl and Enter to run the query. Well, then we get an error because there is one thing that we did not save. We only saved the creation of our external table that was created, but we did not save the creation of the underlying database. That's the reason why this command is not working at the moment. So what can we do? Well, we can simply delete that, like this, and now simply write create database, because that's what we want to do, and we call it again, YouTube population. If we now run this query, well, then we can see that we created our new database right here. And if we now go back to our save queries, now select the DDL1 query once again, and now run the query. Well, then we can see that we now have our database, of course, and we also have our table in here with all our different columns according to the definition or the data type definition that we made. So let's close that now. Now, if we go to Save Queries 2 more times, select the DDL2 query right here and press Run Query, then we should have our second table right. Now it works. Our second table right here. Let's go to Save Queries one last time, select the DDL3 query, and also run this query one last time. And with that, after 3 seconds right now, we are ready. We now saw what we can do with our DDL, our data definition language, how we can change the metadata, how we can create the database, and how we can work on the tables. But this was all related to DDL, as I said. But so far, we didn't actually retrieve or analyze any kind of information that we have stored in our source files, or by that, in our tables. So I think now it's the time to change that. So if you now take a look at the first table, for example, right here, then you can see this I right there. Well, why don't we just click onto that? It says Preview Data. Then you can see that we automatically created a query right here. And this simply shows us all the different columns that we have and the first 10 rows, as can be seen right here. And the query was already performed, so if you scroll down now, you can see that we have, well, as the name says actually, all the columns that we defined and the corresponding first 10 rows. Now, one important information regarding this first table right here. If you remember back S3, then we created that folder and uploaded 2 files. And these 2 files have the exact same structure. They only cover different time periods. And that's really important because, as you can see, Athena simply retrieves the information of the source files stored in such a folder. And if these files are not structured equally, then you will have problems. So keep that in mind when you upload specific files into specific folders to S3 and if you want to query that data with Athena. So it's better to create a new table then, and by that storing the data in a different folder if they have a different structure. That's important. However, we now saw that we can easily see what information we have in our tables by clicking onto that preview, onto that eye actually. Now what's that option then? If we click onto that, then you can see the table properties. So you can see the table name, the database name, the location, and more information. So this is interesting, but not related to our analysis right now, so we can close that actually, like that. So if I scroll down now a little bit, Well, then we can see our columns right here, and let's maybe delete that initial query right here. And now write a function to kind of, well, retrieve some different information out of our source file. So let's start with select maybe. Maybe what can we see? Maybe the population total and maybe the time. And let's maybe also create a sum. Let's maybe say the sum should include, well, the female population, like that. And this new column should be displayed as females. And then we also want to have the location, like that. So that's our select statement. Let's now continue with the table where this should be retrieved from. This should be YouTube. And again, if you press Control and space, then you can easily select the table. So YouTube population table, like that. And let's say we only want to have the data for a specific period, because you can see down here that it starts in 1950. So let's say it should be where time is between, I don't know, maybe 1980, and 2000 only, like that. And it should be grouped, grouped by the total population, right? The time and the location, like that. Let's see what happens if we run that query now. Well, if you now scroll down, to the results right here, then you can see that we now aggregated the data. We have the information of the females for the different locations and the different periods. Here we have 2000, 1980, 1981, and so on. So this is how it generally works. So you write the statement in SQL, and then you can see the results down here. Now, let's try another statement maybe. So let's delete that. Why don't we calculate the share of the female population then? We can simply do that by writing select again. And this time it should be the sum of the, sorry, I don't remember the column name. Let's open it. It should be the sum of the female population, like that, divided by the sum of the total population, for example. It's not like that. It's population total, sorry. And this should be displayed as share female. And additionally, we might want to have the time. Let's do it like this. It should be retrieved again from the YouTube population table. And let's say we want to group it by the time. And now we add something else. We also add order by, again, time, but ascending, in an ascending order. That's it. Let's see if this works. Let's scroll down again. Yeah, it works. So we have the share of the female population for different years, but, well, it's not displayed correctly because we should display that as a decimal. And that's a problem because we defined the data type for the population right here as an integer. And that's why this is not working. So let's first save this query. I think that's a good starting point. Let's maybe save it as query 1 then, like that. Because we have to change the data type of the population, male, female, and the population total. Now you remember that we can change such metadata actually by simply going back to the DDL reference right here. And if we now scroll up again, then you can see that you cannot only change the database or the table, but you can also change the column right here. So if you click onto that, then you have lots of different options, but we actually need the alter column right here. And then we can see, well, change column name or column type. That's what we want to do. So let's click onto that. And if you now scroll down right here, then you can see that you can change the column name and the data type of that column by simply selecting this part right here, copying it, going back to Athena, now replacing it right here, pasting it. So we need to change the table. Well, the table should be YouTube population table, this one. And this should change, now this is the column name, this should change the column name population male, for example, to population male. So the name can be the same, this is fine. But this time to a decimal, like that. And now run that query. We don't see a change so far. So let's maybe change it to female right here, like that, and run the query again. And change also the total population as the last change that we want to do, like that. Well, and we cannot see any change right here, right? That's strange. Let's maybe go to another menu right here and go back. Now it worked. So it only had to update the information. You could also simply have clicked right here. This would have had the same effect. The important thing now is that we now have our values, so our population male, population female, and total population displayed correctly as a decimal right here. Now, if we go back to our saved queries right there and select our query 1, this one, which you can find right here, and now run the query. By the way, also an important information for you. Right here, you can see the runtime of the query and how many data it scanned. I didn't mention it before because, as I said, our data is not really big. But if you have really big data, then you should check out this from time to time to make sure that you don't pay too much for the data that you scanned. However, we ran that query, and if you now scroll down, well, then you can see that now it looks better, right? Now we have our decimals, and now we have the share of the female population for all the different periods. This is great. However, it ends in 2049, and we have 3 source files actually with a total data range from 1950 until 2000. So wouldn't it be great if we could kind of combine the information of the first 2 files, so of the files in this table, with the information in that second table, which includes the data from 2050 to 2001. Now, we can of course also do that. So how can we do it? Well, if we simply keep that and maybe put that down a little bit for a moment, because we have to structure that SQL function right here a little bit differently. Because we want to select the share of the female population, that's totally fine. But we have to change our statement because we need to make a bracket right here and write select like this. And now put that down a little bit like that, right? And well, it should select population female, population total, and the time from the table. This is totally correct. Oops, like that. And now we want to combine the information, so we simply write union all, go to the next row, simply select this part, copy it down, because it's the same thing that we need right here. But now we can copy that again, by the way, makes it easier for us, like that, copy it. But now not from the YouTube population table, but from table number 2. Now we have to close the bracket. Now we can put that up if you want to have it row by row. And with that, if we now run this query, and now scroll down, let's hope it worked. Let's see, now it gets exciting. Yes, it worked. As you can see, we now have all the data until 2100. So we were able to combine the information of 2 different tables. As I said, the important thing is that the structure of these 2 tables is equal. Otherwise, this wouldn't work. So let's scroll back up again. Because now we talked about these first 2 tables, but we also have that third table, this one. And this was the table named error. You remember back in S3, this is this file free error table. Now, what error do we have actually in here? Well, if you click onto the table and select the I and scroll down, then you can see the error really quickly. We have this NA in here. And this shouldn't be in here actually, as I think, because if you want to analyze data, you need clean data. Now, why don't we just get rid of these NAs now? So let's scroll up again. Well, we can keep the select. We only need to delete this part. So we want to select all the columns from our YouTube population table 3, like that. But only where, well, if you scroll down, we can say, for example, where location is not equal to NA, right? Because if we exclude that, then it should be fine. So let's write where location is not equal to NA. Should write like this. And if we now run the query, escape maybe like that, Well, then we see that we cleaned that information and by that got rid of these NA, which is really great. Now, why don't we just use that now and save this cleaned query as a new table? Well, this would be great to be honest, but unfortunately, it's not possible at the moment, at least at the time when I recorded this video. Because the create table as function based on such a query is not supported by Athena. Again, I have to say this at the time when I recorded this. So we can clean the data, but we cannot save it anywhere. No, that's not true, of course. We have an option how to save such information. If you scroll down now, right here, oops, like that, well, then you can see this button right here. This button allows you to save the information, so in that newly clean format, as a CSV. And with that, you could then download it and re-upload that information into a specific folder actually, and by that also query that cleaned information. We won't do this right now because we already saw how we can upload information to S3 and how to query that information in Athena right now. So let's scroll up again. Because with this, we are actually done with our Athena video. Because now you saw how Athena generally works. We talked about the pricing, how to work on tables and databases, how to use the DDL language and that you won't be charged for using that when you change some metadata, and how to use SQL to, well, get specific information out of your tables and do specific calculations. And with that, I hope that you now got a first overview how to use Athena. And as I said, we have an actually small data set right here. But if you have really big data, this also works perfectly and totally fast. The only thing you have to keep in mind is that, well, you are charged for each query that you run, excluding the DDL language, of course. And this means the bigger the data is, well, the more you have to pay. Keep that in mind when you work with Athena. But with that, as I said, we are done with our Athena introduction. There is only one last thing that I would like to show you. And this is how you can now visualize this information right here that you have in your tables in your database. And for this purpose, I want to show you how you can easily connect QuickSight, the business intelligence tool of AWS, to Athena. Let's learn how this works in the next video.